Hey class, this is Professor Nick Stensky at UNC Charlotte, and this is a video for Architecture 2102, second year design studio, spring 2013. This video we're going to talk about just basic introduction to the Rhinoceros interface, and we are going to translate our diagrams that we created in Adobe Illustrator into a lofted surface that you see here inside of Rhino. Okay. So first thing that I want to do is just give you a basic introduction to the Rhino interface. So I'm going to reset my file so that we are basically starting off with what you might see when you first launch the program. We're going to use the template file for large objects feet, and what this does is this automatically sets up the units so that we're working in feet and inches. And it's basically not that big of a deal. So just use the template for large objects feet when you launch the program. And when you open up the program the first time, you'll get 4 windows. And Rhinoceros is a 3D modeler, and we need multiple windows often because we're working on a 2-dimensional screen. And what this is basically an orthographic studio. So I'm just going to make a box here in the perspective plane just to show you. You don't need to actually do this, but if we have a box here in the world, right, we have the top view of the box, which is our plan view, basically, a front view, which is an elevation, and a right view, which is a side elevation. Go ahead. There we go. So anyway, so that's the basic idea. And if you do something to the box in the perspective view, let's say I move it or something, it actually updates, all the other views. Okay, so if you interact with it in one viewport, that's what these are called, by the way, viewports, it changes. Okay, so these are all, you might think of them as sort of like a camera, right? Like if we had a camera on this object, and they just display what happens. And this is useful, right, or necessary, because it's, first of all, very difficult to work in perspective with something because it has distortions. It's very hard to tell exact distances because we have like foreshortening. You can see that with the grid here. See, it starts to foreshorten. We don't want to work in perspective. We want to work in orthographic views because we know what we're getting. We know when we're working in a certain scale, what our operations are. And it's easier to work in 2 dimensions in 2 views than it is to work in 3D. So like so I've been kind of messing around here, but like if I want to center this box, for instance, it's very easy for me to find the center on the origin in the plan view, whereas in this view, like in the perspective, good luck. And if I wanted to put it on the ground line, it's easier for me to kind of move this thing around in one of these other like elevation views than it is, again, for me to do it in 3D. Very hard. Okay, so you need these multiple views in order to work in 3D. Quick, I've been doing a lot of things and I haven't been really explaining what I'm doing. This is called like an orbit, which is basically if you hold the right mouse button down, go ahead and experiment with this. You can move the view around like you're orbiting something, and you hold it down, and so just sort of get used to it. You can when you're in other views that are orthographic, the right mouse button becomes a pan. That's the little hand here. And this is, you guys are familiar with this from AutoCAD, right? So pan, okay, right mouse button, hold it down. If you're in a perspective view, though, sometimes it's useful to pan as well. And to do this, you hold down Shift and you right click, and that lets me pan the perspective view. And the last thing is a zoom, and again, this is probably familiar with this from AutoCAD. We use the mouse wheel to zoom. There are commands for these, like for instance, there's pan, there's orbit. There are various types of zoom, okay, and they're available here as icons, but the most productive way is to get to master the hotkeys in the mouse. You don't want to you want to avoid using icons as much as possible. And that gets me to the next thing, actually, with the software, is that it's very similar to AutoCAD in operation, and that's one of the reasons why we like Rhino so much. We spend a lot of time in AutoCAD. Rhino has a command line interface, very similar, right, where you type in commands. Like if I wanted to make a box again, I could type in box, okay? And you know, it's very intuitive. A lot of the time, when you start to type in something that you want to do, it finishes itself. Again, like AutoCAD. So if I wanted to move the box, I could type in, you know, move, and I would get the move command. And I get other things that are very similar to that I could select also. So it's very intuitive, very nice. Um, if let's see here, so you have those commands, you have the menu options here. You can go through, and you have icons, and you have like tabs with icons. So it's extremely similar to AutoCAD, and also similar to AutoCAD. When you type in a command, you're given instructions and you're given feedback on that command. You're giving the status of the command, and it's just like the way that AutoCAD is. Okay. Okay. A couple of quick things. Now we have the top view, front view, right view, perspective. You can change those by clicking on the little down arrow here, and you can go to set view, and then you can put in whatever view that you'd like. Other useful views are the 2-point perspective, which gives you a view that's more architectural, like it has a focus point. It's a little bit different from perspective, which is almost more like what we would call pejoratively a helicopter view. Okay, we're flying around in a helicopter around this. Okay, you could make it similar to the 2-point perspective view through panning and stuff like that, but the 2-point is just kind of useful because it keeps you in that view. Okay. The other, so other things, front, back. And you can also get a view by typing in the name of the view most times. So if I wanted that to be front view, for whatever reason, I could type in front, and that would give me a front view instantly. Top view. Okay, TOP. So that's really useful. Okay. Perspective is a little bit harder to work with. Actually, there isn't really a good hot command for it. I would just do perspective. Okay. Note that the perspective view changes the drawing plane to whatever the last orthographic view is. We'll talk about this more later, but just so in case you're confused as to why that is, that's why. If I went to perspective from a top view, you get what you'd expect, which is that the ground plane, which is really just a grid for reference. It doesn't actually exist, like it doesn't render or anything. It's just this, is that the plane from the top view. Okay, so moving the camera, the viewport around is really useful. The other thing that's useful is to change the rendering type. And this top list here are what are known as the rendering types. There's a shaded view, and that gives us this box, and it looks like solid geometry now, which is what it is. You can make any view into these, and you can actually, so these are wireframe views. There is a rendered view, which, so you remove the lines, but gives you just the shaded part. Ghosted, which kind of gives us the outline, but also lets us see through the geometry. X-ray, which removes the depth cues of the other piece. And there's technical, which gives you hidden line and basically like a wireframe with the hidden lines. So these are the lines we can't see. They are dashed. Artistic, which I would not use. I don't really like this. Like, it looks like a sketch. It's like too SketchUp-y. Same with pen. There's a slight texture to this, to the background, which I don't like. What I do like about it, though, however, is that it gives you this nice silhouette outline, and then the interior lines are a different weight. It's kind of nice. That's a new thing in Rhinoceros 5. So there's different styles, and wireframe's useful because a lot of times we want to see inside of the object. We want to deal with the vertices of it, and that's really useful. Shaded's useful because basically it's what you're going to get with geometry. You can tell whether something is, has depth, whether it's a surface or a solid. So those are really the only two that you really need to mess with too much at this point. But that's pretty useful. Okay, so that's just the basic introduction to the Rhinoceros interface. If you want to practice, I think a really good exercise to do would be to make yourself a box. So I'm just going to click on the box command, and it says first corner of the base, so I click to make a corner, and then the other corner, I just move around and I click, and then the last movement creates the height when I click, and that gives you a box. If you need something to kind of maneuver around in order to begin to understand how the interface works. Okay, so now would be a good time to like pause this, go back and replay it, get to know the interface, so that you can actually like maneuver yourself around it comfortably. Okay, when you're done, come back and we'll look at getting those curves into Rhino. Okay, so the next part is to start with your Adobe Illustrator file, and I'm going to assume that we did this correctly. It's very good to have a ground line in the file just as a reference. I didn't quite get the layers quite right. I have 21 layers, but basically, if I look at these, I put my two objects on a layer. I have this object here and that object. One's closed and one's open. I did that just because I wanted to look at the differences between the two for you. This isn't particularly good. Don't worry about whether my diagram looks like your diagram or anything like that. It's not really relevant to the discussion. I made these actually just on my own without any reference to the video. I just made them so we can look at them in Rhino. Okay, but that's what I've got is what you've got. I removed all of the image layers because we don't need them for Rhino, and then I saved a copy of the file. Okay, so what I've got is just basically objects that are already organized by layers, and they are proceeding in a linear order from the front to the back. So you would have layers, I don't know, 1 through 24, or like whatever your naming convention was, and you're ready to go. What you want to do is you want to go to File, Export, and you want to save it as an AutoCAD drawing. Okay, DWG. And if I go in and I want to save it as the oldest AutoCAD version, ancient version, we do that because the newer ones have features that I just don't want anything incompatible, basically. And don't worry about the rest of it. You should just use the default options, but just change that. And then you say OK, and it's going to save it. Okay, we're saving it as an AutoCAD file because we want to preserve the layers. And if we just import the Illustrator file, the layers actually don't come into Rhino. And of course, that's a problem. We want to keep things organized. Okay, so if I go into Rhino, I'm going to go ahead and I would just go ahead and start a new file and just open up the large objects again. Start fresh. You go to File, and we're actually going to go to File, Open. You can go to Import too, but let's just do that. File, Open, go to Demo File. You want to change the type to AutoCAD Drawing if it's not already. Otherwise, you can go to all compatible file types. Look at all the different types that Rhino imports. That's one of the things that we like so much about Rhino, is that it can translate a lot of different kinds of files. Okay, so open up the demo file, and the options come up. And let's see here. I think we're going to leave everything as it is. We're going to go ahead and import unreferenced layers, blocks, line types. Don't check any of these. Yeah, these are all fine by the default setting. Okay, click OK, and look at that. Our lines have come in. Our layers have come in, and in fact, even the layer that we locked in Illustrator, which was a ground line, which was a reference line, was already locked when it came in. Okay, so we have all of our layers. We have layer 0, which is a default layer that's just anything that you open up from an AutoCAD file will have a 0 layer with nothing on it, and default, which is the default rhinoceros layer. So those are things that you'll see. You don't need to worry about them. Okay, so I have all my objects, but I have two problems. One, these are sections, and if we're looking at them in our elevation views, they are not oriented correctly. Like, we ought to see this right in the front view, basically, and it's not. It's actually laying flat. It's like we took a drawing in. So we need to rotate those in 3D space. And then the last thing is that they're not to scale. I can just tell you that they're not. I mean, if you look at the grid, this is usually a 10-foot. This is a 10-foot radius, so it's 20 foot by 20 foot. These are enormous, so we need to scale them down to human scale. Okay, which is another reason why you have a scale figure. If you have a scale figure that's a vector, or at least you know what the height of the scale figure was in your Illustrator file, you can easily scale these. And that's what we're going to do. So the first thing I want to do is rotate them in 3D. So I'm going to pick all of them with the mouse. I'm going to select them. Okay, just drag them, and yellow means it's selected. And the ground line is locked, so I'm not selecting it, and that's actually fine with me. I'm going to go ahead and I'm going to turn on O snaps if they're not already turned on. And I want to check end snap and point snap because, as you guys know from AutoCAD, it's very handy to have snaps, right, for precision. And once I've got that, I'm going to go in and I'm going to type in the command for rotate 3D, rotate ROTAT and just 3D, not rotate 3D, okay? Because we want to rotate this in 3D space. We want to basically like take this and like you're raising a barn. If you're, like seeing like an Amish barn raising, right? They would build the side of the barn, on the ground, and then a bunch of Amish people would like raise it up, right? Raise it from 0 degrees to 90 degrees so it's upright. That's what we're going to do. We're going to raise this barn here. So rotate 3D. Start of the axis. We have our axis. It's the ground line. It's really handy. And so what we can do is we can click on one endpoint and the other endpoint to get the axis. That's going to be the hinge of our barn raising. If you don't have that, what you can do is you can click on, the endpoint that touches the ground, and then you can hold Shift, and that's going to constrain you to a orthographically straight line, just like the orthographic constraints in AutoCAD. Draw that hinge. That's your rotation axis, right? End of rotation axis, and then click. And now it says angle or reference point. Well, the reference angle is 0 degrees. So what we want to do is hold Shift again, and we want to go in this direction because that's actually flat. Okay, you can see that in the in the top view and in the perspective view, right? That it's in the same plane as it. It's flat. Okay, and then click, and then the last angle. You can see this barn raising here. Okay, it's ready for us. We're going to hold Shift again, and we're going to constrain it to 90 degrees to raise the barn straight. Okay, and then click, and that's it. You've rotated it in 3D, and look at now our front view has the rotation and it's correct. Okay, the next thing we're going to do is we're going to scale these to proper dimension, and to do that I need something so that I understand how tall they need to be. I could use some math or something to figure out the difference between this height and let's say 6 foot, and then I could calculate the scale and type it in as a decimal using a scale command. But that's pretty hard. What I'm going to do instead is I'm going to draw a 6 foot long line, 6 foot tall line, and I'm counting, this as 6 foot. Yours might be a little bit different if you have people that are jumping or like whatever. Find a reference, you might even say like, okay, that's like, 8 foot 6 inches, let's say, find some number that's going to be something you can scale to and draw a vertical line for that. And to do a line, I'm going to click on the line tool, Polyline, and then it says start a polyline. Well, I'm going to start it at 0, 0. I can actually type in the coordinates 0, 0. Okay, and then the next point, well, if you're thinking about coordinates, 0 in the X and 6 foot in the Y. And I'm doing 6, and I'm doing the apostrophe for the foot symbol. And then next point of polyline, there are no next points. I'm going to click enter, and that stops the command. And I've got my line. Actually, that coordinate plane that I thought was 20 feet, it seems to be 6 foot. Or pretty close. Anyway, I have a line. It's on the default layer. Check. And what I'm going to do is I'm going to select all of my section curves now. And they are, I kind of eyeball moved them to, actually, sorry, they are pretty much on the ground line. There's a little bit of slippage there, but that's okay. We'll leave it at that. What I'm going to do is, since they're already on the ground, I can go ahead and scale them. I'm going to type in the scale command, and then it says origin point, and the origin I'm actually going to count as the 0, 0, the real origin. And then the scale factor, or reference point, well, I'm actually going to use the reference point, so I'm going to look at, and I'm kind of eyeballing this. I'm going to maximize the front view to make this easier for me and for you. I'm going to double click front, and that gives me the whole window as the front view. That's really nice. Anyway, so I'm going to look at, I want to basically get to there. So if I click on, if I move the mouse, it establishes a tracking point at the top point, and then if I hold down Shift, it's going to give me a vertical line, and I can kind of, through the intersection of that reference point and the imaginary orthographic line, I get this nice sort of like tracking point. Okay, and I'm going to click, and then I'm going to move this down, and then I'm going to snap to the endpoint of the 6-foot line that I drew. So basically I took a line that's related to the top point, and I'm just going to touch it to the 6-foot reference line, and that's scaling by reference. And we did this in AutoCAD, okay? And so it's very similar. So if you know what a dimension is and you know what you want it to be, you can scale by reference, and that's what we did. So I'm going to click here, and I've scaled my lines, and then I'm going to go ahead and delete. So I'm going to select that line with the mouse and press delete, and that removes it. I don't want to keep that stuff around if I don't need it. Now to go back to the 4 windows, I can double click front, and I get all my windows. But these are all out of whack, so I'm going to go ahead and click zoom extents. Oh, wait. You know what? Let's go ahead and get rid of the ground line or turn it off, and then let's zoom extents. That's easier. If I right click, I get all the windows to zoom. So now I've got my curves, and they are, you know, in the right right orientation. They're sections, and they are scaled. The last thing is they're not really, see, this is where they are. They're not really aligned on the plane. And to make things easier, when we move them in section, I actually want to align them to the plane. So I'm gonna pick all of them, and I'm gonna say move, and I'm just gonna grab what I think is kind of the center of this, and click, and then I'm gonna say move to 0, 0. So I'm gonna move it directly to the origin. Except shoot, that kind of messed up the plane here. So another way to move is to click and drag. So if I have this mass of stuff selected, I can just click with my mouse where I think the kind of base of it is and hold, and that'll actually let me drag it. And I'm just going to eyeball this so that it comes in very close to the plane. That's what this is here. This axis here gives us an idea of where the ground might be. So go back to perspective view. Yep, that's looking pretty good. And right-click zoom extents to get all the viewports zoomed. Yeah, okay, great. So now we have these things on the origin. They're rotated, they're scaled, we're good to go. Okay. Now the next part is going to be to move these things into position so that we can loft them as sections, right? They're all like stacked on top of each other. They don't have any, in this case, Y depth. You can see the sort of axes here. Z is up. X is headed this direction, and Y is headed in a depth here. So what I'm going to do is, to facilitate this, make it easier, I'm going to turn off as many layers as I can, so I'm only working with like one layer at a time. So I can click on a layer and hold Shift. Oh, by the way, if you're not in the Layers palette, you're going to need to change the tabs here, and just make sure to click on this little piece of cake, looks like. I'm going to say cake. Go to Layers tab, and then I'm going to click Layer 2, and then click my last layer while holding Shift. And I'm going to right-click it, and I go to Set Properties, and I'm going to turn them all off. And there you go. Now you're just dealing with one layer at a time. Okay, and that's our first layer. Okay, what I'm going to do is I'm going to go ahead. I'm going to turn on. So layer 1 is right here. The first layer. These are the first curves. They're going to stay at 0, 0, 0. Or at the 0 Y. If I go to layer 2, actually, turn this off here. Yeah, if I go to layer, I'm going to stay on the default layer right now. I turn off layer 1. You can change layer by double clicking. That actually puts the checkbox, and that says that that's the current layer. I'm going to go to layer 2, turn it on, select these, and I'm going to move them up. And 6 inches. Now the first part of the assignment says to move these, arrange them in a linear order, to add, basically create a series of contours in parallel. You need to decide what the interval is for that collection of contours. For the scale of what I'm doing, 6 inches looks really good to me. You could decide that it's a foot or some other interval. It's up to you, but whatever your interval is, you have to stick to it for this part of the assignment. So what I'm going to do is I have them selected. I have both of mine selected. That's why it's a good idea for each frame to stay on its own layer. That way you can select all of them at the same time. Makes your life a little bit easier. I'm going to go ahead and select them, and I'm going to say move, and then the point to move from, I'm going to go ahead and just click somewhere in the top view is fine. If you have snaps on, that's good because it'll actually snap to its location. And then point to move to, I want to do R0, comma, and then the distance, which is I could say 6 inches, or I could say 0.5 foot, and that's going to move it 0.5 foot. And if I turn on layer 1, you can see that I'm starting to develop those contours. So I can turn these off again. Go to layer 3, turn them on, select them, say move, point to move from, right? Just grab one, and then say R0, comma. Now you want to move it 1 foot, right? Because it's 2 half-foot increments. So 1 foot, and you press enter, and there we go. So you repeat that for all of your layers, making sure to add the increment for each one. The R stands for reference. So instead of, if we just typed in a number, it would be an absolute coordinate, and we don't want that. We want a coordinate that is a reference to the original location, which is the 0y. Okay, so R0 means don't move anything in the x, and comma 1 means move it 1 foot in reference to where you were in the y-axis, which just happens to be 0 in this case. So it makes it very easy for us. Okay, there's no reason why it has to be on the origin if you're using like reference coordinates. But I don't know. I think it just makes it clear. Okay, so you repeat that until you get all of your contours ordered, and what that's going to look like is going to be a minute here. Hide these here. Something like this. Okay, so now you've got all these lined up, and they're all on different layers. Okay. Okay. Next step is to actually loft these. Okay. And to do that, I'm going to try to make things a little simpler for myself. I'm going to go into the front view because that's where these are lined up, and you can do this from whatever view is like convenient. I only want to work on one loft at a time, so I'm going to hide these just so they're out of the way. I'm just going to select them and press and do HIDE. What that does is it quickly removes them from the viewport. They're still in the file. They're not deleted. If you want them back, you can type in show. Everything comes back. Actually, everything comes back. I'm going to delete these leftover lofts. Very clumsy of me. There we go. So anyway, so I'm going to select these and I'm going to hide them for now, just so I'm dealing with only one form. Okay. So lofting is basically taking these cross sections and essentially trying to stretch a surface across them. If you ever get really confused with the viewports and you mess things up, just click on this For Viewports button and that'll restore the default viewport configuration. It's a little tip. Okay, so I'm going to look at these in perspective. Lofting is pretty simple if you have been very consistent and diligent about the ordering of your points and making sure to do copy paste when you were in Illustrator. What the computer's trying to do is basically find the location of one point from one section to another, and that allows it to create the geometry. If it can't, as we'll see in a moment, the surfaces can get kind of cluttered or confused, and you have to do a little bit more work. But if you're very consistent, you can select all of your curves, type in loft, L-O-F-T, and you get these options that come up. What we want is a straight section loft, so you want to change that. You can see different kinds of lofts, look differently. I'm gonna call this a straight section loft though. There's other options, but you don't really need that. And I can press OK, and if you look, you get the loft. You can see how these lines, follow through the form. It's very nice. Okay, so that one's a pretty clean job. Like that loft is not hard at all. I'm gonna go ahead and I'm gonna show everything. And when you're done, you actually have, if I hide this, you actually have the curves that you used to generate it. Okay, the loft is just as a separate surface. And what you can do is you can make a new layer, and I named this one lofts, and then I can click this poly surface. That's another thing too. If you click somewhere and there are two objects, the computer asks you which one you want, and you can kind of go back and forth to decide. And then I want to select the poly surface, so I get that, and then I can right click on the layer, and I can say change object layer, and now that goes on the lofts layer, which was turned off. Okay, I'm going to go ahead and hide these now. And we're going to attend to the closed loft, which is going to be a little bit more onerous and complicated, but not so bad. So if we try to loft these, you automatically get, sometimes you get like a dialog here that says drag seam point to adjust. And what it's basically saying, the computer is saying is like, I actually don't know what you mean. I don't know what point is supposed to talk to what point. Like, am I supposed to carry these across? Did you want these instead? So the computer's asking for your input. I'm going to disable snaps here. If I don't do anything, let's just see what we get. So you can see like it's kind of jumbled. I mean, some of this is really happening though. Like these lines do get traced through the form, but if you look, there are some forms that are inside of others. There's like some twisting. I know you're not really acclimated yet to the 3D software, but you can probably tell that that doesn't look right. Okay, that's because that's not really helping. The form has just kind of been twisted inside of itself because the points aren't really arranged properly. Okay, so we can do a couple of things to fix that. So go back and I just undid the loft command. I'm going to redo the loft command. What you can do that's probably the most useful. Well, first of all, there's a couple of different things. You can do automatic, which attempts to figure it out. Natural, and see that's another. Basically, it's different kinds of algorithms that the computer uses to determine which lines to follow. And one or the other might solve your problem automatically if you look at it and you decide that that's how it should be arranged. If not, though, what you can do is you can manually drag these. So I can click on a point and I can drag it to another point that I can snap to. Okay, so I can just basically click it and then drag it and then click it again. And I can say, no, computer, I actually mean for these to be lined up with each other. Now, you should have the same number of points for every object, and that's really helpful and good. But sometimes it gets confused, like it can't really follow which point is supposed to connect to which, so you have to kind of help it along. The other thing you notice is that these have like a directional arrow. You can see the arrows here. If these arrows are facing the wrong direction, that actually causes the form to twist inside out a little bit, right? You want these all to be facing the same direction. So what you can do is you can say flip, and you can click on one of these things, and it'll flip the arrow. You want all the arrows pointing in the same direction, and that'll help with the loft as well. And then when you're done, just press enter, and I'll go back to shaded view here. And that's slightly better. You don't see any of the, that's a lot better actually. You don't see any of the geometry inside of itself, which is what you want to see. It's a weird form, right? It's not quite as nice as the other one, but you can follow the kind of surface, right? Like this starts as a base surface and really actually stays as the bottom. And then this surface kind of contorts a bit as the points are realigned. You're likely to get something like this, at first. I mean, there's a little bit of twisting here, but the surface is not broken. Not bad. It's not great, but not bad. This is the kind of thing where later on, especially when we talk to Chris, we can kind of massage a little bit. You might want to remove a section or two that's causing you problems. Like it looks like if this section were gone, we might be able to follow this line through a little bit better. And there might be some problems like up here that are similar. We might need to move some points around later. Some of the diagrams transitioning from section to section, like, just don't end up making clean or perhaps good surfaces. Okay, but by manipulating those seams in the viewport and by adjusting their direction, you can kind of untangle it. Okay, it's like a bunch of Christmas lights or something. Okay. A last option that is kind of the nuclear option, because it can be kind of time consuming, but it'll definitely work, is to loft two curves at a time. So I can go to loft and I can adjust these directions so that I am ensured that I get a straight, clean, piece. Then I can click on, if I click on the edge here, I'll get it. Yeah, click on this curve, click on that curve, loft these together. Now, you have to maintain that same order, though, or you can really mess things up. Like, you want to make sure to follow the same point, but at least this way you get a clearer picture of like what the thing's trying to do. Actually, I already spotted something, so I did this, and actually it's just twisted. It's okay, but you kind of get a handle on it that way by doing each one individually. It's very time consuming, but you might find that if your loft is kind of onerous, it's what you need. Like, so now the directions of these are actually going in the wrong direction, so I need to flip this. So don't worry about it too much now. It's just good to get a clean kind of surface out. Okay. Okay. So that is one method we want you to try. So, save that loft on a layer. The other thing we want you to do right now, these are arranged basically in a linear. If we drew a line through them, they're arranged. One other thing you can do would be to move them. I'm holding Shift now and I'm just dragging these. Actually, I'm going to do something else here. You can take I'm going to do an interpolated curve. Just for laughs or whatever, you can try to draw a line using this interpolated curve here, and it should be something that has something to do with maybe the space that's in the video clip that you've looked at, or it has to do basically with something that has to do with your diagrams. And you can take your sections and drag them so that they basically are centered on this line. I'm holding Shift now when I'm dragging so I can restrict them. And you basically take them out of plane. So they're not just like straight lined up, but they actually kind of move. They move a bit more in space. Okay. And so a lot of what's going to happen is dependent upon the curve you draw, the curves you started with. But you keep these from being quite so like straight, and you can experiment with like manipulating them and taking them out of plane. Okay. The other thing I want you guys to try to do is to vary the spacing between them. So right now the spacing is very straightforward, but you could really change the piece if you alter the spacing between the sections. So making certain ones have more distance between them, making certain ones have less distance between them. And don't do this like arbitrarily or seemingly randomly in the way that I'm doing. You really consider where the action is happening in the piece and when it might call for a slowing down, which is to say moving them closer together, or speeding up, which is to keep them far apart. Okay, and that's actually going to create a different effect than just the other loft. It's going to really affect the outcome of that surface. Okay, get these kind of like compression points. Things. So experiment with that. That's the third type. Okay. When you're done, what we want you to do is basically give us some views of your lofted surfaces, so we can understand what it is you've actually done. Okay, and to do that, you're going to need to do a couple of things. So I would go ahead and go into the properties setting and go into shaded view. So scroll down, go to view, shaded, turn off the grid. Actually, don't worry about this stuff. Sorry. Go to shaded and the background. I'm going to say use a solid color, and I'm going to make that white. And that's fine. That's all I need to do. And then what I would do is I would go to grid, and I would go to grid property and say show grid no. Okay. Show grid axes no, and then press enter. And that is going to give you basically a white, white paper, and then this kind of view, and that will allow you to orbit around it. And then when you're ready, you can basically, if you go to view, you can make a capture, and you can say capture to file, and that'll actually give me it crashes my program. But if you capture to file, that'll it should allow you to make a JPEG or a TIFF of that. All right, so if your computer doesn't crash the way mine did, you can use that method to do view capture to file to make the screen captures that you need to basically show your professor on Wednesday what your surface is about. You can use the perspective view. You can use the 2-point perspective view, which might give you more of a sense of the ground. I know we turned off the ground. You may want to leave the grid on just so that you get a sense of where the ground is. It's really helpful when you're doing this to have your scale figure vectorized so that you can use those outlines as a reference for the human scale of your surface. You can show these as a wireframe if that helps. And you could even go in and alter the wireframe properties. If you go up to File, go to View, Display Modes, Wireframe, and we can change the background the same way. Just go in and make that white. It's gonna make your job easier when you're presenting it. Okay, so it gets a little cluttered, but that might be more clear yet than your what you're showing when you're just showing the rendered view. You might even show both. Okay. You can go in, and in addition to this view, you should show us the orthographic views. Your top view, and the right view, and the left, and all that sort of thing. What I would do though, when you do this, is not zoom at all, not mess with it, because these actually will all stay the same scale when you change them. They'll stay the same like zoom level. The perspectives really don't have it because of foreshortening and whatnot, but anyway, it's good to kind of keep them basically the same scale. Even though, again, the Rhino view in this case doesn't really have a particular scale. It is using the same camera distance, which is close enough. So give us enough of these to get a sense of how your surface functions and compile them together into your PDF. Okay. So basically, that's a run through of what we expect you guys to do for Wednesday. So again, you're gonna you can import your curves, create the surface through lofting, and managing that loft, and then basically just showing us a series of images to get a sense of what you produced. If you have any questions about the way the software works, address them to your professor. If you have any questions that are technical in nature, like you can't install it or it's crashing for some reason, you want to address those to the web by Googling them, or to Matt Hodgman or Ken Hagen. Okay, so there you go. That is the Rhinoceros assignment for Module 2. I'll see you guys at school on Wednesday.